Anil Kumar, welcome to my series on vector geometry. One of the most difficult questions which you get on this topic is based on division of line segments. I got many requests on these types of questions. With the result, we have many in our playlists. I'm going to compile most of them here in this particular video, and I hope that will be a valuable resource for all of you to understand how to solve such questions, right? So let's begin with a very beautiful one, which is in the given triangle OAB, C is the midpoint of AB, right? So midpoint means it will divide in the ratio of 1:1, correct? OPPC ratio is 3:2. So O to P is 3 and P to C is 2. So this is 3:2 ratio. We need to find the ratio of OD to DB, right? So we want to find OD to DB. So let's call this as lambda, and we'll call this as 1 minus lambda. Now defining variables like this helps. So if OB is 1 unit long, then OD I'm taking as lambda, so that will be rest 1 minus lambda. Is that clear to you? So that is how we'll actually define our variables. So let this ratio OD to DB be lambda to 1 minus lambda. Now, strategy is we have to pick up a point and define it in two ways. So we'll actually pick up OP, right? So we'll define OP in two different ways, right? One is OP could be written as a scalar multiple of OC. Second, OP can be written as a combination of, we have to involve this lambda. So we kind of, from this side, correct? We can go like this. Okay. So those are the two ways. So one way is as a scalar multiple of this. The other way will go like this. Is that correct? So those are the two ways. Now if I'm saying that OP is scalar multiple of OC, I should know what OC is, right? Okay. So let's begin by saying that let OA be the vector A and OB be vector B. Now, what is AB? So we have OA as vector A, OB as vector B. So we have A to B as B minus A. B minus A, right? B minus A. Okay. Now we want to find what OC is. So what is OC equals to? OC will be OA, which is A, plus, now this is half, right? Half of AB. Half of AB. So which means A plus half of AB is B minus A. So that gives you A plus, let me rewrite this as half B minus half A, and that gives you that OC is basically equal to half of A minus half will be A, right? So A plus B. Okay, so these are vectors. So we got what OC is. OC is half of A plus B. Now what is OP? So we got the basics. Let's write down what OP is. Now OP, we are saying 3:2. That means it is 3/5 of 3 over 5, right? Which is 3 plus 2. So if we divide into 5 equal parts, OP is 3/5 of OC. So that gives you 3/5 of half of A plus B, correct? Or you could write this as 3 over 10 of A plus 3 over 10 of B, right? So these are all vectors. So we got one way of defining OP. Now let's see the other path. So now we will say let OP be equal to what? will go like this: A plus this. So we have to define another vector here. So let's say this is our, let's say t. Okay. So t times A to D. Okay. So it is A plus, what is AD? AD will be A to D we are looking into, right? Minus A. Let's write like this. It will be AO plus OD. Clear? So AD will be AO plus OD. So we have what this. So O to P, we are saying O to P will be OA plus AP, which is T times AD, right? Plus AP, which is T times AD. So OA is A, and plus T times A to D we need to figure out. Okay. So let's find what A to D is. So AD will be AO plus OD, right? So T times AO, which is, let me write, AO plus OD. Now that gives you OA is A, right? Plus T times AO will be minus A, right? OD we are saying lambda times B. Lambda times B. Is that clear to you? Correct? That is lambda times B. Now from here we can write the terms separately for OP. So we can take A common. So we get 1 minus T as one term. The other term will be plus lambda times T times B. Okay, so we get the second equation. So we'll call this as the second equation for OP vector. The first one was here, right? So we have one value for OP, which is 3 over 10 A, 3 over 10 B, and here we have all this. Now, to get the value of lambda and T, we have two variables, correct? So what should we do? We'll compare coefficients. Of A and B. Is it okay? So then we will calculate the answer. So A coefficient here is 3 over 10. Let's call this as equation 1, this as equation 2. So 3 over 10 from A, we are comparing this one, should be equal to minus T, right? So from here we can find the value of T. So T is equal to 1 minus 3 over 10, which is 7 over 10, right? So we get the value of T. Now let's compare the coefficients of B, these ones. So these coefficients for us are lambda times T is equal to 3 over 10. So we can find lambda now from here. So lambda will be 3 over 10 times 1 over T, which is 3 over 10 times reciprocal of this, which is 10 over 7. So 10 and 10 cancel. So we get lambda as equal to 3 over 7. Correct? So lambda is 3 over 7. So we get this value OD is 3 over 7. So 1 minus lambda is how much? 1 minus lambda will be equal to 1 minus 3 over 7, which is 4 over 7. Correct? So this we get ratio as 3 over 7. This one is 4 over 7. So from here we get the ratio of OD to DB as equal to 3 over 4. 3:4, correct? So that becomes our solution. Is that clear? So that is how we are going to solve it. So the strategy here basically is you need to pick up your vector and find the same vector from two different ways. Then equate the equations and compare the coefficients for A's and B's to get your answer. right? So we'll adopt the same strategy for a couple of other questions. And then I think by the end of those 6-7 videos, you will be an expert on this topic. I hope that helps. The question here is, in the given triangle OAB, C divides BA in the ratio of 3:2. So that means this is 3, this is 2. And D divides OA in the ratio of 3:1. So this is 3 and this is 1. So that is the ratio. Point P is on the intersection of OC and BD. So that is the point P to us. Point P is on the intersection of OC and BD. Find the ratio in which P divides OC and BD. Right? So we are given 2 points which are dividing the two sides of a triangle. Now we need to find the ratio in which P divides the given line segments, right? So let's say the ratio is, we'll say T, and so this will be like 1 minus T. You get the idea, right? And the other one, we can take this as S. Then in that case, this will be 1 minus S, right? So if this is 1 unit length, that is S part of it. Sorry, 1 minus S, right? Okay. So that is how we are going to. And we'll need to find the value of T and S basically. Okay. How do we get about this? Now, we know that if C is dividing this point, this segment AB, in the given ratio, we can find what OC is, right? So let's write down our position vectors. So let us say that B is a position vector O to B and A is a position vector from O to A. In that case, what is OC? So we can write OC as equal to what? So from our section formula, we know the total divisions here are 5, right? So the position C can be written as 2 over 5, 2/5, right? 2 over 5 of OB, which is B, plus 3 over 5 of OA, right? So which is vector A. Now this is called section formula, which we have derived earlier. I'll provide you a link on this, right? Okay, so we get the point OC now. We can also find what is B to D, right? So to get B to D, now this is 3 plus 1, 4 in all. So if it is 4 in all, then B to D should be 3 times this vector, which is A, right? Okay. But we can get BD as a combination of these two. That will be better, right? So we'll take like this because A, this is along A itself. So we can say BD is BO. We'll write this as BO plus OD. Okay, that is better. Instead of using this formula, this is better. So B to O is minus B. Okay. And O to D is, we divided A into 4 equal parts, so 3 out of 4. Is that clear? So when you go in this direction, BO, since vector B we have taken like this, right? Vector A we have taken in this direction. So B to D will be BO, OD. So we got this point. Perfect. Now, let's look into OP. So if I see OP from this direction, in that case, OP can be written as T times OC, right? So we have all this. We can write OP as T times OC. which is t times 2 over 5b plus 3 over 5a. Okay, so we get OP in this fashion. Now, we could write OP also in some other way. So we can write OP as a ratio of combination of these two, right? So we can say BP or OB plus BP, right? So we can also write OP as O to P, this vector, as OB plus BP. Okay. So OB is known to us, which is vector B. BP is S times BD. So BD we already found here. So we can write BP as equals to S times BD, the total length, right? Or OP can now be written as B plus S times BD is this. Let me rewrite this as 3 over 4 A minus B. Clear? So it's kind of intricate. So we got the value of BD from here, right? So we'll say, so we got one equation for OP. We'll name this as 1. Let's call this as 2. And then from BD, we substituted 2 here, right? To get another equation in OP. Okay. Now, let us rearrange this so that we clearly get what A and B terms are. So here we get B and this is BS. Let's say B minus BS. And we get plus 3 over 4 AS, right? Okay. So A and B are our vectors. So I could write this as 3 over 4s times vector A. We can take s common here and we get, rather we can take b common, b is common, we get 1 minus s. So 1 minus s times b. That's what we get here. Let's call this as our equation number 3. Now what you see here is that OP has now been written in two different ways. One, we have OP in the parameter t, and another time OP with the parameter s. We are interested in both t and s, right? So what should we do? So from here, what we are going to do is the coefficients of A and B we are going to match and then find t and s. Got the idea, right? So the trick involved here is to match coefficients of vector A and B, right? So that is the trick. That helps us to really solve this question. So what is the coefficient of A in the first equation? 3 over 5t, right? So we'll write 3 over 5t from here equals 2. From here, coefficient of A is 3 over 4s. 3 over 4s. Correct? So that gives us 4t equals to 5s. So we get one equation. 4t equals to 5s. This is by comparing the coefficients of A. This is what we did. Correct. Now, let us compare the coefficients of B, which are these. Here the coefficient is this, right? So we'll have 2 over 5t equals to 1 minus s, right? So that is the coefficient of B. So we can actually cross multiply, right? So we have 2t equals to 5 minus 5s. Now 5s is 4t, right? So we'll substitute this. 5s is 4t. So we get 2t equals to 5 minus 5s is 4t, 4t. So let's solve this on the right side. So we get both the values of t and s. So bringing it to the left, we get 2t plus 4t equals to 5, and that is 6t equals to 5, or t equals to 5 over 6. So we get the value of t. Now from this equation we can find the value of s, right? So we know s is 4 over 5t. T is 5 over 6. So that means s is 4 over 5 times 5 over 6. That is 5 and 5 cancel, 2 over 3. 2 over 3. So we get the value of s as 2 over 3. So we get both the values. We get t as equal to 5 over 6, and we get s as equals to 2 over 3. You get the idea, right? So the value of s is 2 over 3. That means this ratio will be 2:1, right? 2 over 3. So total will be 3, out of which s is 2. And here 5:6. So t is 5, right? So we can now say that the answer is that the ratio BP is to PD, so this side, is equal to what? S is 2 over 3, so this portion is 2. The total is 3, so it is 2:1. Is that clear? The other one, which is OP to PC, is what? OP to PC will be what? So T is 5 over 6. So out of 6 equal division, 5 is this. So it is 5:1. You get an idea, right? So that is what the answer should be. So I hope you understand this strategy. So the strategy in solving these questions is that you have to take the point under consideration, find its value from two different directions so that you involve both the parameters, and then equate the terms which are similar and get your answer. So I hope that helps. The question here is, in the given triangle OAB, C is the midpoint, so that means this divides them into equal ratios. And D divides OA in the ratio of 3:1. So this is 3 and that is 1. Point P is on the intersection of OC and BD. So this is point P for us. Find the ratio in which P divides OC and BD, right? So here we need to find the ratio in which P divides both these vectors OC and BD. Let us see how to do it. Now the approach is that we'll define parameters. So let's say this ratio BT is to, so then we are taking this as 1 minus t, right? The whole is 1. And on this side, let us take this as S, and then this becomes 1 minus S, correct? So the ratio in which P is dividing BD. Now the idea here is to write OP in two different ways involving both the parameters, and then we'll isolate them and figure them out. So let's first find what is OP from this direction. So we know OP can be written as T, so scalar multiple of OC, right? Now what is OC? To get the value of OC, let us write down vector OA as A vector, this as vector B. Right? Should be easy. We'll write the answer in terms of A and B. So now what is OC? OC can be written as O to B plus B to C. So we have written vector B plus half of, because this is half of BA, right? So it is half of B to A Now what is B to A? B to A is A minus B. Correct? Correct. So we'll just open this. So we get OP as basically equal to T times. So if you open this up, you get B plus half A minus half B, or T times A plus B by 2, right? So we get A plus B by 2. So I could write this as T over 2A plus T over 2B, right? In terms of vectors A and B. So we got one of our equation. We'll call this as our equation number 1. Let me write here. Now, let us try to write OP as a combination of this parameter S. So we could write OP as equal to, so we could say OB plus BP. So we say OB plus BP. OB is vector B plus B to P. Now how do we write B to P? Now B to P is S times BD. S times BD. What is BD? BD will be OD, right? So BD will be what? So B times plus S times, what is BD? So B to D is, so we want to go B to D. So we'll come back here. So minus B, right? We go in this direction and then there, which is 3 times A. 3 over 4 times A, right? Plus 3 over 4 times A. Does it make sense to you? So what we did here was something like this. We want what is B to D. So we came here. So this is a negative direction, negative B, and then went like this, right? So 3 over 4, because this is total is 4 parts, 3 plus 1. This is 3 parts of A, right? So that's how we get our equation. Now, let's simplify this one and isolate A and B just as we did that. So we can now write OP as S times 3 over 4A. So we can write 3 over 4 S times vector A. As far as B is concerned, we can take B common, 1 minus S, right? 1 minus S. So that is how we can write this vector. So we'll call this as our equation number 2. Is that clear? So what we did was, we actually found 2 different ways of defining OP, right? And in doing so, we have involved both T and S, the 2 parameters in which we are really interested in. Now, how do we get their values? So we get it by comparing, right? So coefficients of A and coefficients of B. We compare these 2 coefficients to get our equations and we'll solve them. So in equation 1, the coefficient of A is T by 2. So we get T by 2 should be equal to, in equation 2, it is 3 over 4S. For coefficients of B, it is T by 2 for B, and here it is 1 minus S. You see that? So we get our coefficients, right? Now we can solve this. We get T equals to, when you multiply, 6 over 4, or rather 3 over 2S. Now here we know what S is in terms of T, or either way we could write S here, right? So, or we could eliminate, right? So what we will do here is basically T is equals to 2 minus 2S. So we'll replace this value of T with 2 minus 2. So it was better to use T by 2 itself. We could have written 1 over S, right? So we'll just forget about this. We have T over 2 as 1 minus S and T over 2 as 3 over 4S. That means that 1 minus S should be equal to 3 over 4S. Clear, right? So from here itself, we can actually get our equation, right? We get this. T over 2 is 3 over 4s and 1 minus, so they are equal. Okay, this is better. So now we'll cross multiply, so we get 4 minus 4s equals to 3s. Taking it on this side, we get 4 equals to 7s, or s is equals to 4 over 7. So we get the value of s. Now from here we can get the value of t. So t is 3 over 2s, which is 3 over 2 of 4 over 7. 4 over 7, right? So s is 4 over 7. So we get here, that goes 2 times. 6 over 7 is the value of t, right? So we got both the parameters. So we are saying t is basically equals to 6 over 7 and s is equals to 4 over 7, right? So this is cancels 2 times 6 over 7, and here we get 4 over 7. That's correct. So that is how we get our parameter s and t, and now we can write down our answer, right? So we want to know in what ratio p divides OC and BD. So as far as OC is concerned, we can write the ratio OP is to PC is what? Since t is 6 over 7, that means total divisions are 7. So it is 6 is to 1. You get the idea? 6 over 7. So total is, this is 1 out of 7. This is 6 out of 7. As far as BD is concerned, the ratio of BP to PD is what? S is 4 over 7. So 4 here, 3 there. 4 is to 3. So that becomes our solution. Is that clear to you? So that is how we are going to solve such questions. As I have written here, collinear vectors will be scalar multiple with a common point. Now it is very important to understand that scalar multiples will tell you that the vectors are parallel, right? But if they have a common point, then all the 3 points are in the same straight line, right? So that is what we mean when we say collinear points. Perfect. So that is a basic concept. Most of the time I've seen students struggling solving such questions. You really don't find many examples to work with and get practice. This video is going to fill in that gap. So here are very popular questions based on this topic. We'll deal with triangles, points, dividing those sides of the triangles in different ratios, and we'll take up one example with hexagon also. Let us see how to solve such questions efficiently. Question number 1 here is OA equals to A, OB equals to B. P is a point on OA such that OP is to PA is 4 is to 1. So let's divide into half and then half of half. So that is point P for us. Q is a point on AB such that AQ to QB is 2 is to 3. So if I divide into 5 equal parts, so this is less than half. So let's say somewhere here we have the point Q on AB. Now let's write down the ratios in which they are given. This is 4 is to 1. So you could write this as A over 4, right? 4 times A. So we are dividing into 5 portions. So 4A over 5. And here we can write this as A over 5. Does make sense to you? So that makes it, this is 4. 4A over 5. So dividing A into 5 equal parts, 4 is to 1. This is 4A over 5. Then we have A over 5 from P to A. Now this ratio is 2 is to 3. Let me write 2 is to 3 now, since we don't know what AB is. R is a point on OB such that OB to BR is 5 is to 3. So somewhere here, when we extend OB, we get a point R, right? So let's say somewhere there we have a point R, and it says the ratio is 5 is to 3. That means, let me write here 5 is to 3 for now, and then we'll see what it really means. Okay. We need to show that P to Q is 2 over 5B minus 1 over 5A, and show that PQR lie in a straight line. So that means if I join them, it should meet at R. So let me just join them and extend. So wherever it meets the line, I'll write that as R. Correct? So now we have the right diagram to work with. So let us find what AB is. So in this particular case, we can write AB as equal to B minus A, or let's begin by saying OB minus OA. So that gives you AB as vector B minus vector A, right? Since we know now AB, we can write what AQ and QB are, correct? Now we need to find what PQ is. So let's do part A. P to Q will be equal to P to A plus A to Q. Now P to A is 1/5 of OA, which is 1/5 of A, right? And P to Q is, the total parts are 2 plus 3, 5, and it is 2/5 of AB, right? Of AB. Vector AB is B minus A for us. So we'll replace this with B minus A. So we get 1/5 vector A plus 2/5 of B minus A. Correct? Now we can combine the like terms and then get the result. So we'll write 2/5 B first. 1/5 A minus, when you open this, you get 2/5 A. Now, if you combine these terms, you get minus 1/5. So we get our result of the first question part, which is PQ is 2/5 of B minus 1/5 of A. Is that clear? So that is how we are going to do the very first part. Now, let's look into part B. We need to show that PQ and R lie in a straight line. Now, how do you do that? So one way is that we know what PQ is, right? And if we get QR or PR in the same ratio, we need to have a scalar multiple, right? So if we get that scalar multiple part, then we are done, right? So what we will do here is we'll find what P to R is. Now, P to R, but we need to also show that Q is on it, P, Q, and R. So P to Q we know, right? So from one common point, we can find what PR is, right? So that should be okay. So P to R, we could go like this, P to O, right? And then from O to R, right? Then plus O to R. So P to O, we are going now in the reverse direction, it becomes negative 4/5A. And O to R, it becomes, this is B, right? So it is B plus, you have to divide this B into 5 equal parts, right? And then take 3 of them. So that is 3/3/5 of B, right? So that is B to R, right? So let's combine this. We have minus 4/5A, and that gives you 8B/5, right? Now, what is common between these two? We can take 4/5 common, right? So if I take 4/5 common, I get minus A, and here I get plus 2B. Or we could write this as 4/5 times 2B minus A. So that is PR. So PR is a scalar multiple of vector 2B minus A. Here, what we notice is PQ. So I could get this in the factored form. I could factor 1 over 5, right? Then what do I get? I get 2b minus a. Correct? So what we have shown here is that both PR and PQ are collinear. Correct? They are in the direction of 2b minus a. Correct? These are the vectors. Also, we have the second point, and that is P is a common point. Therefore, they are collinear. Does it make sense? So that is how you are actually going to solve such questions. It may take time, it may take a lot of thinking as to what combination to go about. But here, nothing can go wrong. You can get through any path, you will get that result. So that is kind of important to understand. Okay, now let's take up the second question. Now here is question number 2. We'll work with a regular hexagon this time. A, B, C, D, E, F is a regular hexagon with center O. OA is vector A, OB is vector B. Write the vector AB in terms of A and B. That's the first part. Then M is the midpoint of BC. Let's mark it. So BC, we have a midpoint here, M. X is a point on AB extended such that AB is to BX is 3:2. Prove that EMX are on the same line. So that's second thing we need to prove. EMX. Okay. So let's extend AB first. And EM, that means, let me draw a dotted line here. Okay, so we get our point X. So let us see how to solve this. So first part here is to find what AB is, right? So let's find AB. We'll do it. Okay, let's do it here. So A to B is equal to what? Is OB minus OA, right? OB is vector B and OA is vector A. So that is AB for us. Correct? So we got the first solution. Now let's work further. M is the midpoint, so that means M to B is half of A, right? Okay, the X is a point on AB extended such that AB to BX is 3:2. Now this is very critical to understand. We are saying AB to BX is equal to 3:2. We know now what AB is. We need to find what BX is. So in such ratios, it is a good idea to think like this. 1 is to what? 1 is to 2 over 3. Does it make sense to you? Perfect. So if you write like this, in that case, we know that B to X is what? So that basically gives you that B to X basically is 2/3 of AB, right? Do you see that part? Does make sense to you? And we know what AB is. And we have written AB in terms of B and A. Now that is key to solve this particular question. So I hope you get the idea. Now, let's work on the last statement, which is we need to prove E, M, and X are on the same line. So what we are going to do here is we'll find what MX is and what EM. So we get M as a common point. If both are scalar multiples, then they are collinear. Perfect? Okay. So let's begin with M to X. What is M to X? Path followed will be M to B, B to X. Now M to B, since this is a midpoint, BC is same as OA, is basically half of O to A. And B to X is 2/3 of A to B. So this is half of A, and this is 2/3 of A to B, which is B minus A. Does it make sense to you? Do you see how easy the flow comes, right? So that is how you could actually work around. Now we just need to simplify this, correct? So let's simplify and write it down. So let's do it here. So we are going to open this bracket and write m2x as equal to. So we have half of A. We'll write 2/3 with minus sign A first, plus 2/3b. Okay. You can combine these terms. 6 becomes the common denominator. Cross multiplies 3 minus 4, right, of A plus 2/3b. So that gives you minus 1/6 of A, and this is 2/3b. Now when that is the case, you could take 1/6 as common, right? And if you do so, then what do you get? So if I take 1/6 as common, I get minus A, and this becomes 4b. Clear? So that is what we get, minus A and 4b. So we got one part of it, which is m2x. Now let's find what e to m is. Okay, so let's do it in short. E to m. E to m will be, you can go from E to B, right? You can go from E to B. This line extends to go to B, right? Which is 2b. So it is from E to B, and then you go from B to M, right? Now E to B is 2b, and B to M is minus half of A, correct? If I take half common, what do I get? If I take half common, I get 4b, and I get minus A here. Same thing, which is same as half of minus A plus 4b. Does make sense to you, right? So from here, what do we notice? We notice that they are both scalar multiple of 4b minus A, right? So that means they are collinear points. So what we notice here is that to prove this point that E, M, X are on the same line, we notice that EM, this is EM, right? And MX are scalar multiples of the vector 4b minus A. One. And second, we also notice that they have a common point, which is of course M, right? M is common. So once you show that the two vectors are scalar multiple and they have a point which is common, that means they are collinear. They are on the same line. Does make sense to you? So that is how we are going to solve such questions. I hope this concept is absolutely clear, right? A practice question for you, not a very difficult one. I would like you to pause the video, read the question, solve, and then look into my suggestions, right? So we have actually done the tough questions. Now the coming questions are for you to practice. So I'm giving you time so that you could actually take your time, solve them. Question number 3 is, OA is the vector A, OB is vector B, D is a point on OB, E is the midpoint, so that these 2 points are equal, right? So E is the midpoint of AB. F is a point on AD such that we are already given what OF is. Prove that OE and F are collinear. So that is to say, if I join this point here with the midpoint, well, imagine that this point is F, okay? Perfect. So this point becomes F for me now. So you need to show that O, E, F are collinear. Well, as you can see, half of the question has been done We didn't give you the ratio for D dividing O to B. We straight away have provided you what OF is. So it is given that OF is equal to 2 over 5 times A plus B, right? Now to show that OF and E are collinear, we need to only find what OE is. So OE, if you get scalar multiple of A plus B, you know exactly that it is collinear. Perfect. So let's find what OE is. So OE will be equal to OA plus AE, right? Now OA is vector A, but what is AE? A to E is half of A to B, right? Is half of A to B. So what is A to B? A to B is B minus A. Clear? So we get this vector in terms of A and B. We can actually now combine the like terms and simplify. So we get vector OE as equal to, let's open this bracket, A plus half B minus half A, right? Combine the like terms, A minus half A plus half B. That gives you A minus half A is half A plus half B, correct? Now half is common, so vector A plus B is what you get in the brackets. So that means it is also a scalar multiple of A plus B, right? So you see both are scalar multiples of A plus B, right? So now you can write your reason. Since OE and OF, these two vectors are scalar multiples of vector A plus B, and they have O as common point, they are collinear. Does make sense to you, right? So that is how you could actually solve such questions. I hope it makes sense, right? Question number 4. Now here's a very interesting question. You can actually pause the video, read the question, answer, and then look into my suggestions. I'll take a break here. Let's enjoy the wildlife in Canada for some time, and then we'll get back to question number 4 and 5. I hope you enjoyed the beauty of Canadian wilderness. Even in the city, we have a lot of wildlife here. That is very refreshing. Now with a fresh mind, let us see how to answer the two major questions here, which are question number 4 and 5. Question number 4 is, OA equals to vector A, OB is vector B. The point C divides AB in the ratio of 2:3, right? So let me write down 2:3, 2, and this is 3. D is the midpoint of AB, so this is the midpoint, ratio will be 1 and 1. OC, okay, find OC in terms of A and B. So we have to find O to C in terms of the vectors A and B, that's one part. Part B is, OC and AD meet at K. K divides AD in the ratio of n, this is n, is to 3. Find the value of n, right? This is a very interesting question and kind of difficult. Let us see how to solve it. So I hope you remember the formula for a section formula. When you divide a segment, let me share this formula with you. So you can look into my videos where we have taken up a couple of examples based on this concept. So if I have a point like this C as shown here, A and B, let us take this situation, and if the ratio in general is m is to n, right? In that case, OC can be written as n over m plus n times the vector A plus m over, I mean this side m, right, over m plus n plus b, right? So this is a standard formula which we use for division of line. It can be utilized for external and internal both, right? If it is external, let us say somewhere outside, then we take negative value, right? So n becomes negative. So we are straight away going to use this formula and write down the result. So for us, what is OC equals to? So OC, sum is 2 plus 3, 5. So that 5 in the denominator is clear, right? So when we say multiply with the vector A, we take this number 3 here, right? So that is key, right? So 3 times vector A, which is OA, plus the other portion 2 gets multiplied with vector B. So 2 over 5 times vector B. So in the test, you could actually use this formula and straight away write that OC is equal to 3 over 5A plus 2 over 5B. Is that clear? Right? Now we are going to use this formula again to find what OK is, right? So let's say what is O to K. Now O to K, the ratio is n is to 3. So the denominator will be n plus 3, clear? You multiply 3 and with this vector A on this side. So it is 3 times the vector A plus, here we get n plus 3, numerator will be n, and the vector will be O to D. So let me write O to D here for the time being. You get an idea, right? So that is how we are going to work on it. Now O to D is half B, right? This is half B, right? So these are the vectors. OD is the midpoint. So we can write this as 3 over n plus 3A plus n over n plus 3 times half of A. Half of B, right? Since this is O to D is half B, correct? Now, so that is how we are going to get our equation. Now, what you notice here, if I take 1 over 5 as common, in that case, what do I get the ratio as? Right? So the ratio between these two is what, basically? So when we have this condition that K is on the same line, then this ratio of the coefficients of A and B should be same. You're getting my point, right? So the idea here is that they are going to be on the same line only if the ratios are proportional. Right? So what I'm trying to say here is this ratio, coefficient of A and coefficient of B, should be same. So we get 3 over 5 divided by 2 over 5 should be equal to this ratio, which is 3 over n plus 3 divided by n over 2 times n plus 3. This ratio should be same, right? Only then they are in the same line. They are scalar multiples, right? Since O to C and O to K, they are collinear, right? Since collinear points are scalar multiple. Let's write down. That really means that O to K is some lambda times O to C, right? So their ratio is the same. That is what we're trying to say. Does it make sense to you, right? Okay, so let's simplify this and figure out the answer. So this 5 and 5 cancel. This n plus 3 cancel. So we get 3 over 2 equals to 6 over, now because this is n over 2, right? So we get 3 over n times 2, right? So 6 over n, right? So now you can cross multiply. Let's do it here. So what we get here, we can just cross multiply, right? So if you cross multiply, you get 3n equals to 6 times 2, 12. Or n equals to 12 over 3, which is equal to 4. You could do that. You could even cancel this 3, cross multiply, get your answer as 4, right? So that is how we are going to solve it. So we get the value of n as equal to 4. So we get n equals to 4. Do you see how we found the coordinates of the point, right? So the key here was to understand this portion. That whenever you have collinear points, these ratios are fixed, right? Now based on this, we have now a thinking question, which is question number 5. Let's try. Here is the last question. I hope you have learned all the concepts and you're confident to take this up. Question number 5 is, OA equals to 5A, OB is 2B. The point C divides CO in the ratio of 4, it should be OA, right? This is divides OA. Point C divides O to A in the ratio of 4:1, right? That is what it is. D is a point such that ADDB is 1:2. So this D somewhere here is 1:2. The line OB is extended to get the point E. Given CDE are on the same straight line, find BE. Very interesting question, right? It's very different from what we did so far. So anyway, let me just construct this. Now, you need to find vector BE. So that's the question for you. You can pause the video, answer the question, and then look into my suggestions. Use the knowledge which you have learned in this set of videos, especially the last question which we did. Okay, now let us see how to do it. Now, basically, we need to find what CD and CE is, and their ratios should be same, right? Since they are collinear, C will be a common point. So that is how we are going to work, right? So let's find what is C to D. So C to D is, you have to move up. So when we say 4:1, total is 5A, that means we can say this is 4A and that is A. So C to A, let's write CA first, plus A to D. C to A is vector A and A to D is what? A to D is 1/3 of A to B, right? 1/3 of A to B. Or 1/3 of A to B is 2B minus 5A, right? We are doing some shortcuts. I'm not writing OB minus OA, right? At this stage, you know all this. Okay. So we got in terms of A and B, and that has been our first step always. Let's open this up now. So we get 2 over 3B minus 5 over 3A. Let's combine the like terms. So what do we get? We get 2 over 3B And here, as far as A is concerned, okay, let's rewrite. A, so we'll cross multiply. So we'll have 3A minus 5A over 3. Does make sense? Right. Okay. So we get here 2 over 3A with a negative sign. So we get here 2 over 3B minus 2 over 3A. Right. I hope you can see it on my screen. Okay, let me just rewrite this on this side. So what we got here is that C to D is basically equal to 2 over 3B minus 2 over 3A, right? So that is what we got. Now, let us see what is C to E. So C to E will be, we can go like this, right? So when you go like this, you CO and then O to E, plus we can say O to B, okay, we know that, and then B to E. Now B to E has to be a scalar multiple of P. So let me write this as K times B, right? Okay, so C to E will be, C to O is minus 4A since you are going in the reverse direction. O to B is 2B, and this we have taken as K times B. So now, as far as the B coefficient is concerned, we get 2 plus K as coefficient of B, and for A, we have minus 4A, right? So that is what we get. Now what did we learn? We learned that these ratios should be same, perfect? So now let's equate these ratios. So we have 2 over 3 over minus 2 over 3 should be equal to, so first we wrote for B, right? So 2 plus K over minus 4. Does make sense, right? So this gives you minus 1, right? This is minus 1. Now you cross multiply. So when you cross multiply, you get 2 plus K equals to 4, or K equals to 4 minus 2, which is 2. So we get our answer, which is K equals to 2. Perfect. So that is how we are going to find the vector. So the vector here is what? So the vector BE is basically equal to 2B. So that becomes our result. Does it make sense to you? So that is how we are going to solve questions which are related to collinear points and where geometry is the key to solve questions. I hope you understand and appreciate what we have done here. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Thanks for watching and all the best.